In this video, we're going to learn how to use Python to automate things for us, so we don't have to do them manually. We're going to do something super cool and interesting. We're going to automate two use cases. First, we will write a Python program that takes any blog article or any web page, and it extracts all the headers from that page or article. And then it translates all those headers to Spanish and saves it into its own HTML file. So you can open it in the browser and basically see all the headers of that specific blog article translated in Spanish. And the second use case will be that we're going to write a Python program that goes through all the files in our downloads folder. It then checks if we have any files that are older than 30 days or were last used more than 30 days ago. And it takes all these files and puts that into a new folder called to delete, which we can then review and basically delete if needed. So basically it helps us clean up our messy downloads folder with a bunch of old downloaded files in there. But here's an even more interesting thing we will do. We will use an artificial intelligence tool that you probably have already heard of a million times called ChatGPT. And we will tell Python to use ChatGPT's API or the underlying API that ChatGPT is also using to generate the Python scripts for those two use cases that I mentioned. Now, if you haven't heard about ChatGPT by now, also not a problem because I have a full video on that, which I made recently, which I will link in this video. So basically, we are going to write a Python program that will accept an input from us about the automation use case, and then go to ChatGPT and say, hey, give me a Python script for this automation use case. And then we'll save it into a separate Python file. I think it's a really cool thing to try out. And I hope you find it just as cool and exciting as I do. So let's get into it. But before we start, if you have watched our videos and they were helpful for you, please subscribe to support us as we keep on creating more free, valuable content for you. So if you're getting value from this channel, just take this second and click the subscribe button. If you don't want to miss any new videos that we post, then you can also activate the notification bell. Before we start, many of you may be asking, why does everyone use Python for automation? There are so many other programming languages out there and they all seem to be doing pretty much the same thing. So what is it with Python that gives it a monopoly on automation? Well, the magic is in the ecosystem of Python libraries for automation. So Python is a very simple language, and it just happened that most low-level automation tools were written in Python. So now you have this huge ecosystem of Python libraries that can talk to the server operating system, to cloud platforms, allow configuring infrastructure, networking, accessing various APIs. And this may be very small standalone libraries or a complex automation tool like Ansible, which also happens to be written with Python. So basically a lot of work and effort got concentrated into that, which means if you want to automate something, you have a specific use case in mind, you can be sure that there will be a great Python library for that specific automation use case. And if it doesn't exist yet, probably someone will create it very soon. Whereas for other programming languages, you won't be able to find library for every automation task, or the library won't be as powerful or user-friendly as the Python library. So because of that, Python just ended up being the language when it comes to automation. And when you think about this and compare the different programming languages, every language is kind of good at one specific thing, right? So even though they're all programming languages, and at its core, they're pretty similar, every programming language has its strength in one particular area that differentiates it, that makes it the best language for that area. So for example, Java is robust, mature, and a good choice for enterprise software. JavaScript is used to write web applications, and Python is the language for automation. So let's get into the demo part. Let's first write a Python program that connects to the API. I said ChatGPT API, but technically it's an OpenAI API, which is what ChatGPT uses under the hood. So OpenAI's API is the application interface that lets us connect to it and interact with the artificial intelligence that drives and powers ChatGPT, for example. And many startups and developers actually use this API to build some cool new tools. So how do we connect to the OpenAI's API in general, regardless of what programming language we're using? Well, first of all, you need to quickly sign up to create an account on OpenAI platform. This way, you are kind of creating your own space on OpenAI for your user. And one of the reasons that you have to sign up is that all the compute resources needed and the processing that takes place by the artificial intelligence in the background needs some compute resources and processing power. So obviously they can't provide these limitless to everyone. So they have some limits per user so that everyone can equally access and use these for free to a certain point. So the first step is to sign up and create a user account on OpenAI's platform. And once you have your user account, the second step will be to create what's called an API key, which is random generated string, which is a unique key that is associated with your user account, which means when we use that API key in our Python program to make a call and connect to the API will know that it's associated with our user account. And by the way, this concept of creating an account on platform and using an API key to identify your user by making a request to it is a very general concept of using an API, nothing specific or unique for OpenAI. It's that simple. So we need those two simple steps to prepare everything and get started using this API. So let's go ahead and do that. Either open this link directly or you can even Google OpenAI API. And it shows you exactly the same page, right? So right here on the OpenAI's page, you basically do sign up, create your account, just providing your email address and some information. I actually already created one, and just log into your account. And that is your personal space. And now let's create the API key, which we will use in our Python program to connect to the API. So clicking on your user account icon here, view API keys. So it's pretty simple actually. And you will probably have 0 keys at the beginning for a fresh new account. So go ahead and create a new secret key. I'm going to click on it. Obviously, I'm going to remove this later. But before you click OK, make sure to copy this secret key somewhere safe and accessible because we're going to need that in our Python program. So I'm going to copy that. OK. And after that, you won't be actually able to see that or access it. So make sure to paste it somewhere. And that's how easy it is. So we have the account and we have the API key to connect to the API. Two things I want to mention. First of all, if Python syntax and Python generally is completely new to you, then you can check out my Python tutorial where I go through all the basics, including the variables, if-else statements, functions, syntax, and all these basic concepts. So you can learn how to work with Python. And the second thing is we need to have Python actually installed locally so that we can run Python program. If you don't have Python installed yet, for example, if you're on Mac, you will probably already have Python. If not, you would have to install it. So you're going to have Python 3. So that's the new version of Python. And you execute that with Python 3 command actually, like this. And you also need to have Python package manager installed, which is called pip, also with 3. So if you go through my Python course, you will have all these tools installed and you will know basics of Python syntax. So you should be able to easily follow this specific demo. So let's start writing this Python script and we will see what we need and how to put together this code step by step. So first of all, I'm going to create a separate folder for all the Python scripts that we're going to produce in this demo. So in YouTube tutorial series folder, and I'm going to create a new folder and let's call this Python ChatGPT. And I'm going to change into that folder. And now I'm going to open these inside Visual Studio Code. And there you go. You can also just open Visual Studio Code and then open the folder from this UI. I just used a shortcut. So this is a folder where I'm going to put the Python script. So let's create it. And I'm actually going to also call this Python script Python ChatGPT.py. And we can just start writing our script. So first of all, whenever we connect to an external API, we're making a request. So we're going to need a library, a Python library in this case, that will allow us to send requests to external endpoints like API endpoints. Now, how do we make a request to OpenAI? Well, we actually have two options. We have a generic requests library, which is great because you can use it for whatever API or whatever tool you want, not just OpenAI. So it's generic, and when you learn how to use it, you will be able to make a request to any API. But usually, the tools that provide the APIs will also provide a library that hides the underlying complexity of making a request, setting all the parameters, etc., or setting the API key, and lets you interact with the API with a more high-level code. So in that library, they will give you objects and methods and so on that make the whole process easier. And generally, that's the purpose of a library, right? To make writing the code easier for us so we don't have to write everything from scratch. And OpenAI has a library for Python and Node.js, for example. And you can see the usage of the library for each language, and you see that it's called OpenAI. So that's the library name. So you can install OpenAI library and import it in your code and use it like the example you see right here. You can see the syntax and how to use the library in the official documentation of that specific tool, like what methods or objects you have available and so on. And this will be very useful if you're doing more complex things and making more complex queries to the API and you want to use the library to do those things without overcomplicating your code. But OpenAI is pretty recent and its library may change, like they may change methods and syntax and so on, because they're still adding and developing a lot of stuff on top of that, so things may change. So if you're gonna watch this video maybe a year later, it may look very different. And because of that, I'm gonna stick to the generic request library because we just wanna make a request, which is a pretty simple use case. So the code between using the request library and OpenAI library will not be very different. And also, I think it's better to learn the things that you can use for many other things as well. Maybe it's just my personal preference, but in any case, for this example, I'm going to use the request library. As I said, it shouldn't make that much difference. If you want to, you can actually go with the OpenAI library and use it instead. Not a problem at all. So you see here, it's a module for making HTTP requests. And in Visual Studio Code, you even see a cheat sheet of how to actually use the library, which is pretty cool. So now we have a library that helps us make requests to external endpoints. Now we have to find out what is the endpoint of OpenAI API that we want to connect to. And remember, we're writing a Python script that takes our input, which is going to be any automation use case. It will then go to the API and say, for this specific use case that user entered here, I want to have a Python script. Just like you would type into ChatGPT, please write a Python script for this specific use case. So we're doing that, but programmatically. So now we have to find out the endpoint that allows us to do that. Where do we find endpoints of an API? Well, in the API documentation. So right here in OpenAI platform, you're going to click on documentation. And this is basically a description of how to use this documentation and what does this API provide. And again, whatever API you're using, it will always come with the documentation because obviously you need to know how to use that API and on which endpoints you should send what request, right? So if we scroll a little bit down here, you see the section prompts and completions, which is the core of this API as they are stating here. And this is exactly what ChatGPT uses. You input some text as a prompt, and the model will generate a text completion that attempts to match whatever you asked from it. And there are a bunch of other stuff, but the completions is exactly what we need. So either you click here, and it takes you directly to that completion section, Or if you scroll down in the API reference, you also have this completions section, which is basically the same, right? So we have our endpoint. I'm actually going to copy that and add that into my code and save it into a variable. And I'm going to call this API endpoint. We also have our API key. Let's actually also add this right here. And you should have copied that somewhere. And now you can just paste it in. And by the way, your API key is a secret key. So it's actually a sensitive piece of information. You shouldn't be sharing that with anyone, and you shouldn't have that directly in your code. So later, when you have the script ready, we're going to remove this API key from here, and we're going to read that from an environment variable. So it's not hard-coded inside the script, but we're going to do that later. So we have those two pieces of information. We have the endpoint, and we have the key that allows us to connect to and authenticate with the OpenAI API in general, so that it can actually take our requests and answer them. So we're getting there slowly. Now that we have the endpoint and the key for authentication and the library to make a request, it's now time to actually make the request. And again, we're going to refer the documentation to see how to generate our request. I'm going to switch back. The first piece of information we have is that we need to do a post request. So instead of get request, where we're just getting some data, we are making a post request, which means we are expecting to get some data back. However, we need to first send or post our prompt to get that request, right? So we have to send some information and then we'll get the reply to that. And in order to make a post request with the requests library, we have a simple post method. And this post method accepts several parameters. The first one is API endpoint, because request library needs to know where are we posting this data, which endpoint are we connecting to. And now we need to define what information are we sending in that request. And there are two pieces of information, or two types of information we're sending with the request. First one is the metadata about the request, and the second one is the actual request contents. So switching back again, and again, this is not specific to this API, this is how the requests are structured. So the metadata would be things like the token or API key for authentication. So it's not the actual content of our request. It's not the prompt that we're saying, hey, please give me Python script for this use case, but it's more like additional information about the request itself, which is, here's my key to authenticate that I'm allowed to make this request. Again, it's part of HTTP. We send the metadata as headers. So we're going to set the headers on a request. And by the way, if you look to your right, and let's actually make this larger, you have the example request, which we can use as a reference, which you can basically just copy and it will make the request with those parameters. And as you see, this is a curl request, which you can execute on your terminal using curl command line tool. And again, very conveniently, they also provide this same request example in Python and Node.js. So Python is what we need. And remember, I told you that we have two ways of making a request to OpenAI. One is using the request library, basically a library that provides us a generic way to make a request to any endpoint. And the second one is the OpenAI library itself. And this example right here is using the OpenAI library. So this is an example code of how to make a request using that library. However, I said that we're going to use request library because our use case is pretty simple, and you can then go back and compare the OpenAI library example with what we write. So because I'm going to be using requests library, I'm actually going to switch back to curl, and I'm going to take the information from here. So we have to map that now to Python request. And these are HTTP headers where it's setting the API key and saying that it will send requests in a JSON format. So let's set those two headers, which is going to be the second parameter of the post method. So we need our headers equals to, and we can either directly write those headers inside as an object, or we could also save that into a separate variable. Let's call it headers or request headers, and set those two headers that we need right here. So we have the content type I'm actually going to copy those two, which basically says that we're sending content type of JSON format. So that's the format of the request that we're sending to the API. There you go. And we have the header to set the API key. Now, obviously, we have to reference or substitute the API key. So either you can type it directly here, like this, a string. However, because we want to have a clean code and we're storing things into variables, we're going to reference it here, simply like this. This is how string concatenation syntax looks like in Python. So we have the string, and this is just a reference to a variable. So we're setting the headers, and we can set that value as a second parameter. So now the post request is made to that endpoint with those headers, and now we need the actual request, what's called the request body. So now the contents of the actual request come, and that's going to be the third parameter of post method. And again, we can have an object here like this, or we're going to create another variable. We're going to call it data or request data. Let's call it request data. We can also call this request header like this. So we have a little consistency. There you go. And now let's see what we need inside that request data. Going back, we have the example here. And these are basically the request data, right? Things that we include inside the request. And this is an example request, and this is the full list of parameters. So these are things that we can include in our request or request data to basically communicate with the API endpoint and tell it exactly what we need, right? So let's go through these parameters and see what options we have here. The first important and required attribute is what's called a model. And this actually refers to the machine learning model of OpenAI that we want to use. And as you see, as an example value, it has text DaVinci 003. So what is that? What is a model? Well, if you watched my ChatGPT video, I explained what models are a little bit. However, we can go through this here as well. And if I open this link that says model overview, we're going to see a couple of items here. These are basically group of models. And if I scroll a little bit down right here, GPT-3 that powers ChatGPT, that's where the name comes from, has a list of various models. So basically, OpenAI is an organization that works on various different types of AI tools. It doesn't just work on AI that produces text or visuals. It works on different types of AIs. And because of that, they have various models that specialize and do different things. So GPT-3 is actually one of these model groups for processing and generating natural language. And this is a list of machine learning models that OpenAI has developed and uses in its projects like ChatGPT or DALL-E or whatever. And also the machine learning models that you can connect to and talk to through the API. And you see the descriptions here. So text DaVinci 003 is basically the name or ID of that model. That's how they called it. And as it says, it is the most capable model. It has been trained with massive amounts of data and can do very complex things. And you also see it has been trained with data up to 2021. Of course, this may change. If you watch this video 1 year after I release it, obviously you may see different stuff in this documentation, but currently that's how it looks like. So that's what a model is. And when we connect to the API, we can basically select which machine learning model we want to talk to. Well, in our case, we want to generate a Python script, which is maybe a little bit more complex task. So we're going to go with the best option that we have, text DaVinci 003. And that's also the example that we have here. Now, before we move on and use the text DaVinci model in our request, I want to mention another model group that is listed in the overview called Codex. So just from the name, you know that it's about code. And this is basically a set of models for coding examples specifically. Now, this was actually created on top of GPT-3 models. So it builds on top of the capabilities of GPT-3 models. But it has been trained with extensive amount from open source code on GitHub, and it produces code. So if I click inside, you can see a detailed description, how it's been trained, and that it's most capable in Python, plus proficient in other languages. And it has these two models under its group. Now, here's the thing. I actually tested it out to compare it with the GP3 model, and it didn't really perform consistently. On some occasions, it didn't actually produce proper results. However, when it actually gave the proper response, it was a nicely written, well-structured code. So I think there is a lot of potential there, but it didn't work for all the use cases. You can also see that it's in beta version. Maybe after a couple of months or a year, when you're seeing this video, it will not be in beta anymore, just like the other model groups. So because of these reasons, we're actually going to choose the GPT-3 model called TextDaVinci 003, which works perfectly for our use case, and it actually generates really good code as well with consistent results. So that's what we're going to choose. However, the great thing about using this API in our example is that you can literally just replace the model name with any other model names that you see here, including the two models under Codex group, and basically just test it out and see for yourself. You will not have to adjust or change anything in the code. You will only replace the model name and basically compare them if you want to. So even though we are going with this option for the demo, you can safely use CodeDaVinci instead and basically just compare the results yourself. So choosing the right model here is not a big deal because you can replace it later very easily just by changing the name of the model. So that's the model I'm going to choose to make our requests. So again, when you use an API, you can choose between those models, and that's the model we're going to choose. So that's going to be our first parameter. There you go. The second most important parameter in our request is obviously the prompt, because prompt is the main part of the request that tells what we are asking for exactly. And again, for a comparison, prompt is what you type in when you're chatting with ChatGPT, for example. In this case, we're sending that prompt programmatically inside the request. And let's change this prompt, and we're going to tell the TextDaVinci model to write Python script for hello world. Super simple, right? Because we just want to test that we make a request successfully and we get a response. So prompt is done, and we have a couple of other options here. But from those options, these two are probably the most important. So what are these? Very simple. Max tokens basically limits the response that you get in tokens. So with these parameters, generally, we are controlling the behavior of the API model when generating the text. So this specifies the maximum number of tokens, such as words or punctuation marks, that the API model should generate in its response. And I'm going to set these max tokens to, let's do 100 for start. The hello world script obviously is going to be very small, so it's not going to need 100 tokens, but we can set it to maximum 100 tokens. So it's not going to exceed that amount. And we have one more parameter, which is called temperature. It's also very simple. It basically defines or tells the machine learning model, hey, when you're generating this response, make sure to be super creative, like go crazy with your creativity. And that will be a temperature of 1. Or we can say, hey, machine learning model, please be as precise and predictable as possible. And that will be temperature of 0. So with 0 and 1, you can control that, but obviously have everything in the middle. So with 0.5 temperature, we can ask the API engine to generate a response that is half creative, half predictable. So I'm going to copy that, and we're going to set it to 0.5. And we're actually going to ignore the rest of the parameters, which are the most important ones. And once we have our request data, we're going to set that as a value for this JSON parameter here. So we have pieced together our request. So this is actually ready to connect to the API and get a response. So again, to walk through this, what we're doing is using the requests library, we are connecting to the API endpoint of OpenAI and completions. We are including the API key that is associated with our user account so that OpenAI can say, okay, I know this API key and it's associated with this account, so you are authorized to make requests. And once we have that authorization, it will then take our request data and see what we are actually requesting. And it will see we want to talk to Text DaVinci 003 model, and we want to ask it to create Python script for hello world. Please do not exceed 100 tokens in your response and be somewhat creative, but also more predictable. And then we will get a response. And we can then save this response into a variable called response. And of course, we want to see the result of our hard work, which means we want to print out the response and see what we actually got. So I'm going to do print response.json. So here we're getting a response, and the response is also in JSON format, just like the request that we sent. So with this header content type, we define that we're sending JSON, and we're also receiving JSON response. And this is how we can grab that JSON response using .json method. Now, of course, when we make requests, when we run programs sometimes have errors, so some issue may happen. So what we can do is we can first check, was our response actually successful, or maybe had an error? If it had an error, then we won't have a JSON response. We're not going to have any contents or any normal response contents as JSON, so we can print out the error message in that case. So what we can do is we can say if response status code. So we have status code for success, which is 200, which means everything was fine. The model got our request. Our request was valid, so we didn't make any mistakes when creating it, and it was able to come up with a response, which means status code 200. And in that case, we print that response. If not, which is else, we're gonna print request failed. Maybe we sent a wrong request, or maybe the API server is down, or whatever reason, request failed. And we want to also know the reason why it failed. So we're going to print out the status code. And this will be a reference to response.status code. And in Python, this is actually Python syntax. If you want to use a reference to a variable inside a string, we have this really nice shortcut or syntax where we add f before that string starts. You see the syntax highlighting also changed like this. So now Python knows this is a string, and whatever is within these curly braces is actually not a string, but variable reference. And this is going to be a number. And in Python, we can turn the numbers into strings using this very simple str or string built-in function. And this is our super simple Python script for connecting to OpenAI API. So now it's time to execute this Python script. So we have Python 3, which we need to execute the Python script, and we have pip3 Python package manager to install any libraries that we are using in our Python script. So you need to install requests, because we are using a library called request, which is actually external library that isn't included in the Python package, which means you will have to install that using pip3 package manager. So it's a Python package that needs to be installed. I have already installed that, and because of that, first of all, my Visual Studio Code shows this quick prompt with the examples, etc. However, and let me demonstrate this, if I go back and if I uninstall, so pip3 uninstall requests, and let's remove that. And if I go back, you will see what happens. And that's going to be your case, or how you see the code in your Visual Studio Code editor. You will have this yellow line underneath, and if I mouse over, it will say import requests could not be resolved because we don't have that library installed locally. So even before running the script, Python says, I don't know where to find this library. I can't import anything called requests. And that will be your state if you don't have that installed, which means either globally on the terminal or right here in the project folder, you're going to do pip3 install requests. There you go. And now we have installed requests, and it shows that documentation reference again, no squiggly lines here anymore, and it will work. And now that we have library installed, we have Python 3 installed, let's execute our script. Using Python 3 and the name of our script, which is Python ChatGPT.py. Let's execute. And I have actually made a small syntax error here, which is this part. Just like here, it has to be a valid JSON object, like this. Or for consistency, we can actually use double quotes. And there you go. So that should fix our attribute error, since we now set the attributes with valid syntax. So let's execute our script again. And there you go. We have a response output. So right here, where we're printing the JSON response, that's what we have right here. And as you see, the response is a JSON object. And we have a couple of things that we received as a response, in addition to the actual Python script that we requested right here. So just like we have metadata on request, we have metadata on response as well. It says that it's a text completion object, which model was used, and so on. And inside this choices attribute, we have text attribute that actually contains the Python script that we asked for. So right here, this statement is the Python print function to print hello world, which is the response to our prompt that we set right here. And let's say we don't care about all this metadata about the response. We only care about the text that we're getting. So we can ignore all this other stuff, only print out the response text. So on the JSON object, we're going to grab the value of choices. And this is Python syntax. We're going to say, give me the value of choices, which is an array, as you see. And we're going to grab the first element of that array. Again, I teach the syntax basics in my Python course. So if you want to know what arrays are, what objects are, how to use them, you can learn all of that there. And then from the first element of that array, we get this JSON object, and we want to get the value of the text attribute. So again, give me the value of text. And now this should print the value right here. And let's see that actually. Let's execute again. And there we have it. By the way, when we're executing this Python script, we're making a new request, just like when you enter a new prompt into ChatGPT. So this time it gave us a new response with very slight differences, like edit a comment here on the top and this line here for Python executable. So we have actually created a program that connects to DaVinci text model of OpenAI, and now we can send whatever prompt we want programmatically, and we're going to get a response back from that API that we're connecting to, which is pretty cool. So let's try one more example, and let's ask the API to write Python script for, let's say, printing out today's date. And let's see what we get. And look through the code. It imports datetime library and prints out today's date. Now, if you have used ChatGPT already, you know that it usually gives you additional explanations in a text form on top of the code, and you might get that here as well. Again, it's the same API, so you might get the same results when you access it programmatically. And the text can be helpful, but usually if you want to quickly generate Python script, you don't want to have those explanations and text. You're only interested in code. So in that case, just to make sure the API returns only the script and no additional text, we can actually adjust our prompt and tell API to only send us the code. So right here, I'm going to say provide only code, no text. So we're just telling API what we want. In my case, it shouldn't be much different because it already gave me just code, but it may be different in your case. Let's execute that again. And in my case, it just removed the comments, which are kind of unnecessary because the code itself is pretty self-explanatory. So we can leave it at that. Going back to our main goal is we want this Python script to take our input whenever we start the script of what use case we want to automate with Python, right? So basically this prompt here, it shouldn't be hard-coded here, but rather it should just take input from us and then execute that as a prompt. So basically write Python script for blank. So this is going to be our input for whatever use case we provide as an input, and then the rest of them will stay the same. The things that will always apply, such as we always want the Python script and we always want the code and not the text. So this one needs to be parameterized and taken from user input. How do we get user input from Python? It's actually pretty easy. We have a library called argparse or argument parser. Import argparse. There you go. And different from the request library, which we had to install using pip3, we don't need to install argparse because it is actually a built-in module. So it is already part of the Python installation. And again, you see the description here. It basically lets us parse the command line arguments that we provide to the Python application when we run it. So it will look like this. That's the Python script execution. Right here after space, we're going to provide our use case as an argument. And the argument will be provided like this. So write Python script. Let's change this to print today's date. So that's going to be the argument that we're going to parse inside the Python script and then use it here. And this is a code to read the user input. We're going to use the argparse argument parser object. Let's save it into parser variable. So this is an object that has a method that allows us to read the parameters or arguments that we provide here. So this basically, this part here is an argument that we pass to the application. So addArgument method takes two parameters. The first one is the name of the argument. So it's kind of like assigning the whole value here to a variable. So let's call this prompt because that's what we're providing. And then optionally, we can add description of what that prompt is. And that's a help attribute. And we're going to say this is a prompt to send to the OpenAI API. And finally, using this parser object, we're going to call a method called parseArgs, which is going to go through whatever arguments we have added here. And it's going to read the first argument and say, this is a prompt. If we had second argument and we edit here, it will assign it there. So basically parse any input we provide here, and we can save it into the variable called arguments. Argument, the word in this case means the input that we provide to our script. And now we can access this value using args.prompt because we called this value prompt, kind of like assigning to a variable. And we're going to use that right here. Again, the Python syntax for using a variable within a string. So we have args.prompt. And of course, we have to use F to tell Python this is a variable reference and not a string. So again, now when we execute our script, we have to provide an argument because we are expecting it now in the application, so we can't just leave it. Otherwise, we'll get an error. And when we provide that with these 3 lines of code, the argument parser will basically register that input or argument with the name of prompt. And then when we parse the arguments, we can access it using arguments variable.prompt. So now let's actually execute this and see how it works. So executing the Python script with this input, let's see what comes out. And there you go. As I said, every time we execute this script, it actually makes a new request to the API, and we're getting a different response. That's why it looks different than the previous ones. Let's try another example, like print hello world. And there you go. So now, without having to modify the prompt here in the code, we can just easily pass on whatever use case we want to have here, right? Let's do some other simple example. Let's say write Python script to calculate number of days from, I don't know, let's say 1 million minutes. And let's say what we get, and there you go. So these are obviously super simple examples. When we have the script ready, we're gonna actually execute our 2 use cases of extracting the headers from a blog article and translating to Spanish, and then cleaning up your downloads folder with all the files that are older than 30 days. So we have parameterized our script. So we're passing in the prompt as an input. We have 2 more things to do before we're done with this specific script. The first one is we want to save the script, whatever we get here, right here as a result. We want to save it into a separate Python script file, right? So instead of having that in a console and having to copy that and create a new Python file, we want that to happen automatically. And as I said at the beginning, having an API key directly here, since it's a sensitive data, is actually not a good thing to do. So we're gonna extract that into an environment variable. Both of these things are very easy to do, so let's quickly add them here. So first of all, let's write a code that instead of printing it out to the console, it just saves it into a file. So let's remove the print here, and instead let's save this into a variable, and let's call it response text. So this is the attribute that contains our code. And then we're gonna create a file, and we're gonna write whatever the response text is into that file. Very easy to do with Python. So we have a keyword with open. So this will basically open or create a new file, and we need to provide a file name. For now, let's call this output.py. So it's a Python file, and the open method takes a second attribute, which is either we can write the contents to this file, or if the file already exists and there is some content, we can instead append to the previous content. In our case, we always want to write it from scratch, so we're going to use W. So that's basically the mode in which we want to open this file. In write mode, append mode, and so on. And we're going to say open as file. So this line basically goes and tries to find a file called output.py. If it doesn't find one, it creates one, and it opens it in the mode that we specified right here. So in this case, it will create a new file and open it in write mode. Now that we are in a write mode, we're gonna write to that file using file.write. Super easy, as you see, and just providing the contents we want to write to that file. That's it. These 2 lines basically allow us to save this response text into a separate Python file. So let's execute and see that it works. And there you go. We have an output Python file. If I open this, we have the script that API returned inside. And as I said, when we have the write mode open, if we change the use case, let's say print hello world, it will overwrite whatever is inside output script. Let's see. There you go. Instead of appending, it will just overwrite or replace whatever was in there. There you go. Now, if we want to use this Python script to generate files for multiple use cases, we want to save those use cases in separate files, right? We don't want to keep overwriting in this single output file, right? Which means we want to create a new file every time we generate a new Python script. So instead of hard coding this value or file name here, we're going to also pass that as an input. So we're going to tell Python, please send a request to generate Python script for this use case, and then please save it into a file with this name. So we can provide that as an input as well, which means this will be a user input also, and will look like this. So this is the use case or prompt, and the second parameter will be the file name, like hello world.py, for example. And the same way as we did before, we need to first register this argument and then give it a name so we can use it right here. So going up, I'm just going to copy this line. Let's call this file name, which it is file name of the file to save Python script. There you go. So we have the second argument, and we can access it using args.filename. Very easy. So args.filename. And now if I execute this, we should get a new file with this file name and the response text inside. Let's do that. And we have this hello world.py with print hello world inside. Awesome. So that's one thing we wanted to optimize. The second one is to extract that into environment variable, which is even easier. Just gonna copy that, and instead of hard coding it directly here, we're gonna export an environment variable. Let's call it OpenAI API key. You can call it whatever you want. Let's remove those quotes. So this will create register environment variable in this terminal session. So you have to do this in the same terminal session where you execute the script. So let's execute this one. But now we have to read that environment variable OpenAI key inside Python script. And we do that using a module called OS. And then we execute OS, get environment, and the name of the environment variable as a parameter. That's it. So this line will read value of this environment variable and assign it to a Python variable here. And again, you have to export this environment variable before you execute the script in the same terminal session. So that was our final optimization. Let's actually delete those and execute our script again. And there you go. We have our result, and we're not exposing our API key in the code. And with this, our Python ChatGPT script is done and ready to produce other Python automation scripts. Now let's go ahead and use our script to generate Python code for our first use case, which is going to be going through a blog post. And I have an example blog post that we're going to use, which is this one right here. And it has different levels of headers. You probably know headers from HTML. So we have larger ones, and then we have some subheaders like this, and so on. So basically, the script will go through the whole blog post. It will extract all those headers. It will translate those headers into Spanish, and then save that into an HTML file. So when we open it, we basically will see this blog post, but basically compressed in just a list of headers, translated into Spanish. So let's go back to our script and let's ask it to generate Python code for this use case. And usually when interacting with API, it's important to formulate our prompts properly so it understands exactly what we need. So let's write, we want a Python script to extract all headers, or let's say HTML headers from a web page translate to Spanish and save the result into an HTML file. And whatever Python script this provides, we want to save it into a Python file. Let's call it extract and translate headers.py. So let's execute this and let's see what we get as a result. And also to know that your result may be very different to what I'm getting, because again, it will generate a different response every time we make a request. So the file was created. Let's look inside. First of all, we have this dot here. Let's remove that. And let's look at our code. Now, this is an interesting part. As you see, it basically gave us a code which is not finished, right? So we have a syntax error here because it hasn't finished with the result. And the reason for that is if we go back to our ChatGPT Python program, you remember when we were creating a request, we set this parameter called max tokens, which basically limits the number of tokens or characters that you get back as a response. And because we have set a limit of 100, we basically got those 100 tokens here. So we didn't get the complete result, which means we want to increase that so we have enough tokens to get the full response. So you know what? I'm going to set it to 500 just to give us enough amount. And let's try again. The file has changed. Let's go back. And let's look through our code. Just one glance, it actually looks pretty good. We can definitely work with this. So let's go through the code that we got as a response from the API. Let's see if there are any adjustments needed, and then we're gonna test this program with our example blog article. So first of all, we're using the same requests, a library that we used here, because this is a generic library that you can use basically to make requests to any URL. This will be the URL of our blog post. So let's change that right away. I'm just going to copy that and paste it in here instead of example. And then using the requests library, we're just requesting that page. And on the page, we can access the content or the text of that page. And this is a library called Beautiful Soup, which is a very popular Python library for extracting, crawling, and basically working with websites. So anytime you want to extract some information from web pages, this is a library that you're going to use. It is very powerful and it is very popular. And it was also suggested for this specific use case by the API. And that's the library name, BS4, Beautiful Soup 4. If I hover over it, you see the description that basically parses the whole HTML into a tree representation so you can then access individual elements of that HTML page. So that's what we're doing here, parsing the page contents, the whole HTML, using an HTML parser. It also works with XML. We're specifying that this is an HTML page, and we're saving that result here. And this is a line where it goes through that tree representation of the HTML page, and it basically finds and grabs all the headers on that page. So these are HTML header attributes, and we're saving that array of headers and their values, of course, into headers variable. So this is a part where the headers are being extracted, and this is a part where they are being translated. As you see, also very easy code. It's using Google Translate library. And again, we have a description. So Google provides this Translate API for free, which is amazing. And you can use that in your Python scripts to translate whatever you want. So this is initiating the translator. And this is the code section that basically takes the header text and translates it into Spanish. So that's the destination language to be translated into. And it then collects back those translated headers into this Spanish headers array. And this is a basic for loop. You learn about for loop in my Python course, but it's super simple. Actually, it just goes through the headers or the header elements, and it says for every header, give me the text. It will translate it into Spanish, and then add that into Spanish headers array. So now this array will have list of all the header texts in Spanish. And the final step is where it's creating an HTML file with HTML opening and closing tags. You already know this because we used it right here. Basically opens the file. Once it creates this Spanish headers.html file, which is amazing, also came up with a pretty good name. And then between those HTML tags, it basically goes through the Spanish headers array. And for each header, it adds this h1 with a header text. Now, overall, the script looks pretty good, actually. It's surprisingly good for the very first request. And we don't need almost any adjustment except for this last part, because since we're extracting headers of all levels, we don't want to then save them as h1, right? We want to keep that hierarchy of headers and titles and subtitles. So we want to also reuse them right here. So that's the only part we're gonna adjust. And it's also pretty easy. So what we're gonna do is, instead of hard coding these h1s here, we're gonna take that information from the header element itself. So we're gonna need to do a little bit of adjustment. So first of all, going back here, this only saves the header texts, right? The actual values of those headers, like this one, for example, and it discards the rest of the element information, including what element that is, right? Whether it's h1 or h2 or whatever. So we want to keep all that information, including the text. So we're gonna collect not only the text, but the whole elements. So now these individual header items will not be just the text, right? Not just this text value, but the whole HTML element, which has the type, which is h1, h2, h whatever, the text, and so on. This means the actual value would be header.text. We have used it here as well. And we will have a value called header.name, which represents exactly what type of header that is. So I'm going to copy that here as well. And that should preserve the hierarchy of headers in the final HTML file as well. Now we can actually go ahead and test this and see if we got everything right or if something else needs adjustment. So let's go ahead and do that. However, before we execute the script, we need to install all those libraries. And if you haven't installed them yet, you will also see these yellow lines underneath. And I can show you actually. So if I uninstall them, because I have them already locally, let's confirm. Yes, give it a little bit of time. This will be your state. So before you execute the script, you will simply need to do pip3 install bs4. So let's do that. And you also have to install Google Translate library. But in my case, it didn't work with the latest installation, so I had to use a specific version. So we're going to provide a version here as well. So it's going to be 3.1.0a0. Let's install that as well. And that should fix that underlining. Again, there you go. And now with all the libraries, all the dependencies installed, we can go ahead and execute our script. Extract, translate headers. Let's see. So we got an error that says no attribute name. So it seems like whatever this one, this translate result is giving back, does not have a name attribute. It only has text. So to debug that, let's actually see what is inside. Let's do translated or translate result like this, and let's print this out. And if we look at any one of those items, like this one, for example, we see that it has those attributes like source, destination, text, which is translated into Spanish, which is great. And it doesn't have the header name attribute, which is fine. We can fix that also very easily by grabbing that information from the header. So in the Spanish headers array, we can basically save an object that has the header text, the translated header text, and the header name. So we're going to prepare that object. Let's call it translate result. So this is going to be an object, and it is going to have a text, and the value of the text will be the translation result dot text attribute, right? Because we saw that this part here gives us the whole translate object back, this one, and then we have to basically grab the text from it. So that's going to be our translated text, and then we have the header name, right? And we're going to grab that directly from here, header name, and that's it. And finally, we're going to add that translate result. We can also call this translated header and add that to the Spanish headers array. So now in that array, we don't only have just a list of texts. So this will create a Python dictionary with text and name attributes with the translated text and header name attributes. So the header name will be a value of h1 till h6. And we're appending or adding that dictionary into Spanish headers array. And here, as we're iterating through that list of dictionary, we're going to grab the name attribute of the dictionary and text attribute. And we learned the syntax of accessing the dictionary attributes is square brackets and the name of the attribute, which in this case is also the name. Also, notice that because we're using single quotes here for the whole string, we have to use double quotes inside, because otherwise we're gonna get an error, because it's gonna think that this basically ends the string expression, right? So just watch out for that. And again, let's grab the text attribute of the dictionary and the name attribute again. And let's execute the script and see if it works. So the script completed. We didn't get any errors, which is a good sign. And we have our Spanish headers.html file, which should now contain all headers translated in Spanish. And it looks pretty good, actually. Now, the last thing we want to do is go ahead and open this in a browser. And I can actually just drag and drop it into the browser window like this. And there you go. Looks pretty Spanish. I personally don't know Spanish, so I can't tell how precise and correct the translations are, but that's up to the Google Translate library. The rest of the stuff looks pretty good. Actually, we have our header hierarchy. So we have the larger headers and the subheaders. We can even inspect that in the browser. And let's see. There you go. So we have H2, H4, all levels of headers in our HTML file. Awesome. So that gave us the first script for our first use case. And I think the code that we got from the API was actually pretty good as a starting point, because we only needed to do a couple of changes and it worked pretty well. Now let's go ahead and generate Python automation code for our second use case. So I'm going to close this one, and we're going to ask our Python script to give us Python code to go through files in downloads folder, check their dates, and if they are older than 30 days, move them to folder called to delete. So that's our use case. Let's say I have a very messy downloads folder where I never delete stuff from. I just leave it in there. So it kind of gets pretty messy and crowded. And I'm going to ask a Python script to basically just go through all the files and make sure that it leaves all the recent downloads in the downloads folder, but everything older than 30 days should be moved to a separate file called to delete, which I can then manually just go through and move to trash if I want to. And we're going to save it into a file called clean downloads.python. Let's go. And there you go. We have our clean downloads Python. And again, it added some weird line at the beginning. I'm assuming this is a kind of leftover of text explanation that API is returning. Let's remove that and let's see what we got here. So we have 3 libraries that we're using, the OS module that we already saw. Then we have another module that is basically used to copy, archive files and folders on our file system. And finally, we have datetime that we're going to need to calculate whether files are older than 30 days. So let's say what this auto-generated script does. First, it sets path to downloads folder in user's home directory, which is good if I don't want to basically provide the whole path, like users, my username /downloads, basically just expands or uses the user's home directory shortcut. Then it provides another path for the new directory called toDelete. This is really good because it checks whether the toDelete folder already exists. If not, it creates one using this OS module. So OS path exists, basically just checks whether file or folder exists, and make_dir creates a directory. Pretty straightforward. Then it's going through the list of files inside the downloads folder and saves them in the files variable. We're getting the current date. And then for every file in this list of files in downloads folder, it gets the file's modification date. Then it checks the time difference from now and the last modified. So if it's a recent file, like it was modified yesterday, the time difference will be 1 day. If it's an old file, it hasn't been used longer, then the time difference will be higher. So here it checks if the time difference is higher than 30 days, then using the shutil module, it moves the file from downloads folder, the file name, to the toDelete folder. This actually looks pretty good. It used the right libraries, the code is pretty simple. It even added those comments on top. The code is also nicely structured. I actually thought that I would have to adjust way more in the final result, but it seems pretty good. So let's actually execute this. I do have lots of files in my downloads folder, which a lot of them are probably way older than 30 days. So let's execute Python 3 clean downloads.py. I'm really interested to see if this works first time. And it seems like my downloads folder was cleaned up. So right now I have those 5 files left. And if I click inside those, you see that they have been all modified recently. So these ones were today. This is modified like 17 days ago. And in my home folder, it created toDelete directory. And as you see here in date modified, all the files and folders inside have modified date, which is more than 30 days ago. So the logic worked, moving the files worked, and we got exactly the result that we needed. I am genuinely impressed that we didn't have to modify anything at all to make this code work. Amazing. And you even have the comments on top of those sections that say exactly what it's doing. Really, really good. So yeah, we have generated a couple of Python scripts that automate some things. And we also have the Python program that we can feed any automation use case that we want, and it will generate a Python script for us. I'm really happy with the results. I hope I was able to teach you some valuable skills and things in this video. Please comment in the sections how this whole demo worked for you, or whether you had any issues and what results you get, or how qualitative and how good the results were that you got from the API. And finally, just share some other valuable and really practical use cases where you think you can use this Python automation, and maybe some more examples that I should cover. And with that, again, thank you for watching and see you in the next video.